welcome to the LMI webinar series. My name is Vanessa German and I'll be your host today. Today we have with us Marion Zitko. She's field application engineer at LMI, and Lucien Flögitz. He's a territory manager at LMI, and Lucien has a lot of experience with food applications. So he will share his expertise with us today. Just a few notes before we get started, and I hand it over to Marion and Lucien. This webinar is being recorded. So if you need to leave for any reason, don't worry. We will send you a recording later that you can watch. So just look out for that. Might land in your spam folder, so check that if you don't get the email. On the right-hand side, you'll see a chat function. So if you have any questions during the webinar, feel free to write your questions there. We will do our best to answer all your questions at the end of the webinar. Yeah, so I think that's it. Without any further ado, Marion, Lucien, take it away.
Okay, then it's up to Marion and me to tell you a little bit about 3D inline inspection solutions for food processing applications. We will start a little bit about the LMI Technologies company. LMI is a company which headquarters is located in Vancouver, Canada, but we spread it out all over the world. So we got offices in Americas, in Europe, and in the East. So everywhere we have local offices with also local support. That means if you have an application with one of the LMI sensors, you always have in your time zone a support technicians available for assistance. All the yellow dots on the map are our distributors. And as you can see, there's in over than 40 countries. So we more or less cover the whole world with local contacts. LMI as a company is selling a lot of different products, which we have our brand name, which is called Gocator. And in Gocator, we serve you with several 3D scanning technologies. One of them is laser triangulation. The other one is structured light. And the third one is line confocal profiling. If we go to food applications, I would say that 95, maybe close to 100% is laser triangulations, which is the image on the left, where we project a laser line and where on most of the time a moving conveyor, so moving products are being measured. If you would use structured light, then your products have to be stationary, and the sensor is positioned stationary above the product. And from that situation, we create a 3D image. Line confocal is a technology which is very high resolution, but very small ranges, so up to 16 millimeters in width, for medical, very difficult products to measure, but not used in food, at least at this moment at all. So we will focus this presentation on the laser triangulation technology. If we talk about measuring in food, a lot of the applications are done with 2D, a camera, lighting, and some processing. LMI's company only focus on 3D vision. So we take height in account as well. So we got X, we got Y, and we got Z, the height. The advantage of using a 3D vision system is that you're contrast immune. That means for 2D, you need contrast to get an image. As soon as you use 3D, there's no reason for any contrast. So a black conveyor with black products, as long as there's a high difference, can be measured using 3D vision. So the question you normally get if you start with a project where vision is required, what is the color of the conveyor, is not interested when you use 3D vision. So it's an ideal one for inspecting low contrast objects, but of course there are more positive things about 3D vision. It's also the immunity to ambient light. So it means it performs in variable lighting conditions. Whether it's completely dark or you just turn on all your lights in your factory floor, the 3D sensor will keep measuring without any adjustment. Where 2D might go blind, this technology is almost immune for ambient light changes. The other nice advantage of not 3D vision, but the way LMI sells their products, it's that a factory calibrated sensor. So you just take your sensor out of the box, you mount it above your conveyor, and it's automatically already pre-calibrated. X, Y, Z is just a calibrated millimeter value. If you use 2D and your height changed from your products, you have to recalibrate, or your width length measurements are not correct anymore. Using this 3D sensors, height is not an issue. As long as you're within the range of the sensor, everything is being calibrated. So that means that you can do volumetric measurements. So besides width and length, we also can do height. We can do not only area, but also can give you a volume measurement, but also give you the shape when it has a shape and height variation on that product. These are the main advantages of 3D vision. The way LMI sells those products is that it's also very simple to integrate, but that's something which we can discuss later. I go to the next slide. And that one goes over to Marion.
Thank you. So now we will go a little bit deeper in our subject and talk about the 3D inline applications we have in food industry. So we have a lot of Gocator which are used in the food market. For example, fish and meat, fruits and vegetables, dairy like cheese, sweets, etc. Typically, for those products, we measure the dimensions like length, width, height, the volume. We are looking for potential defects, and we check the position and orientation of the product. The advantage of our Gocator is that we have a smart solution, automated, non-destructive, and cost-effective way to meet the high standard in the food industry regarding the production, quality, and safety. So we will use the 3D and 2D images provided by the Gocator to achieve 100% optimization and quality control across a wide variety of applications. Usually, when we start with a food application, the first requirements are simple. For example, can we check the volume of the chocolate cream in each container? But after diving into the project, we discover new potential needs and challenges. For example, could we also check the position of our cover on the cream? Or could we get the position of the containers on the conveyor and give them to a robot to pick and place each container? Type of applications are wide-ranging, starting from measuring a raw product, in our case the volume of chocolate cream, all the way to control final product like the cover on the chocolate cream and guidance of packaging with the robots. In case we would like to inspect more than just the top of our product like previously, we can use what we call a multi-sensor setup with several sensors to generate a single 365 degrees point cloud. For that, we will use multiple Gocator. One of the Gocator is the main sensor, the master, and the other Gocators are the buddies. The buddies will forward their information to the main sensor, and the main sensor will reconstruct this single 365 degrees point cloud. In this application, we use 3 network Gocator. We have one on the bottom and 2 on the top. We will use it to scan a piece of meat, and with that, we will be able to determine the total volume. And this information about the volume as well as the density information is used to optimize the slicing of the piece of meat. For this second application, we also have a multi-sensor setup with 2 Gocator. You can see them on the top of the conveyor with an angle. And with this system, we are scanning blocks of cheese and we communicate the 3D shape for automatic cutting. Indeed, cutting and slicing, for that to do that, 3D dimensions are needed to optimize the cut location. And this is used to be sure that each portion of cheese has the same weight. Here again, we have 2 Gocators angled, but we are scanning a dough on a conveyor. So for each dough, we will generate the 3D point cloud, and we will use it to get the dimensions, the location and orientation on the conveyor, as well as the height. And those data is required for quality inspection, sorting, and robot manipulations at the end of the conveyor. Here again, we have several sensors, but they are independent from each other. So the 3 Gocators, they do not communicate, but each one is scanning lane of potatoes on a multi-lane conveyor. For each potatoes, we generate the 3D data to get the volume, the length, width, and height of each potato. Those measurements are output directly from the Gocator into the PLC. You don't need any PC between both. And the PLC will activate air fingers to sort potatoes in bins by industry standard size. Now, this is an application we have for food industry with potatoes, but typically something we could for something else like sorting stones, for example.
Okay, thank you, Mario. I will take over. So what we have seen right now is that a lot of different applications in food industries where, as I said before, we're using in most applications, all these applications in line laser profiling. Mario showed applications where we could do a single sensor, even if you mounted several side by side because you want to do multi-lanes. But she also said some sensors where we do have a what we call ring setup or wide setup, and that's to measure also on the sides. You can imagine if your sensor is mounted from top, we only see what you also with your eyes can see on the top. If you want to see a little bit from the side, you have your rotate your sensor slightly and look from the side to get that perfect data. Cookie inspection is a inspection which we did for a customer where they want to see the dimensions of cookies. And then they went up to a conveyor width over 2 meters, 2400 millimeters to be exactly. As soon as you mount one of those sensors on that conveyor, you will get shadows on the side of the cookies. Because the laser comes from a point into a line, it will create on the side a small shadow on the cookies, and we're not really measuring the exact width of the cookies due to that shadow, which we call occlusion. So to overcome these occlusions, what we did is we mounted multiple sensors with a 50% overlap. And in addition, we did the sensor who did the overlap also reverse. So we scan the front, the end, the left and the right side without any occlusion. We call this a bodied Gocator setup. Within the Gocator family, we have a system which we call a master unit, which automatically synchronizes all sensors. And in that complete setup, it becomes very easy to get a 3D image from multiple sensors, which looks like it comes from one sensor. So in this setup, this application, the main task of the system is to measure dimensions of cookies, but without occlusion. So we have to see the side of the cookies, but also see whether there is a defect on the surface, thus actually find cracks. And this was also a very nice challenge. It has to be done in very high speeds. I have to press the right button to go to the next slide. If you look at the system, which you can see on the right top, you see that we have mounted there multiple sensors. This setup has 8 sensors, but we went up to 12 sensors and even testing 14 sensors at this moment. You see that the sensors have an overlap of 50%. So the laser from the first sensor and the second sensor just overlap 50%. The third one overlaps against the second one with 50%, the fourth one and the third sensor with 50%, and so on. That means that when one sensor has an occlusion, the data will be filled in by its neighbor sensor. This is a very nice way to get rid of occlusions. It only gives you an issue because you need to align those sensors perfectly to combine all the data into one image. In the LMI Gocator tool set, we have tools to do up to 6 degrees of freedom alignment procedure. And that means that we can do an automatic alignment of the movement of the sensors in X, Y, Z, but also 3 angles. The application itself requirement was quite high speed. So we went up over 1 meter per second in scanning speed. Data has to be streamed to a computer, which runs Halcon. It has to be 24/7, so we don't get any room for rest. It has to be a continuous stream of data. In between, we did something with a PTP synchronization so that our system and a robot, which was further on the line, and other systems have to be synchronized. And it has to be a system that has easy to be scaled, because some installations are just 1 meter in width, the other one 2 meters in width, so they had to be scalable. If you look at the system, how it's been built, or how it's been measured, is that we have in this configuration, like I said, 50% overlap. And this, what we show in this picture, is a screenshot of our Gocator web GUI. And we just took simple cookies for ourselves for a test. It looks like it's a 3D image from just one sensor, but this is a combination of multiple sensors. And like I said, we went up here up to 12 sensors, almost 2.5 meters in width. We did 6 degrees of freedom alignment correction, but still sampling at 3 kilohertz. So you will get 3,000 laser lines of 2.5 meter each second on a continuous stream. If you get that amount of data, it's high resolution data. You also have to take account what computers you're using. If your speed of your Ethernet switches is correct, it's not just the measurement system, but also the system behind to really capture the data and process the data. In general, the resolution we achieved was 0.25 in X and Y, which was what the customer was asking for. If you want to see how it looks in reality without showing the name of the customer, you see on the right top 3 boxes in a 19-inch rack mounted. The one on the bottom is the computer. The middle one is our Master 810, which all sensors are connected to. This one can connect up to 8 sensors. We also have a Master 2410, which can connect up to 24 sensors. Each sensor connected into that box is synchronized with all the other sensors connected to that box. And the one on the top is an Ethernet switch to just combine the data and transfer the data to the computer. If you look at the image of the installation, you see in the middle a big box. In that box is where all the sensors are located. As you can see, this is a customized mounting from that customer where all the sensors are located in. And on the blue conveyor on the left, you see a bar with some flat pyramid kind of shapes and holes. That's the alignment bar, which is needed for 6 degrees of freedom alignment. So what you do in general is you mount those sensors inside the mounting box. You connect the sensors, and then you put this calibration bar on your conveyor. You move that once underneath the complete system, and then it's automatically, we calculate all the transformations for each sensor. So all the data can be combined into one image, and you're more or less done. So as soon as you have to place one or multiple sensors, the only thing you have to do is place this calibration bar on your system, run it once underneath the system, and you're ready to go for your production line. On the left, we show you a little bit the specifications of the Gocator 2370, which we use for this product. It's one of our sensors from the 2300 series, 1 megapixel, and it can go up to 5 kilohertz sample rate. Then we have an image on how the cookies look like in our web GUI. So this is what comes with the Gocator. And as you can see, we see in green the conveyor, and we see the cookies data without any occlusion. If I go to the next slide, it's a more closely look. This is not a mesh, but this is the actual points, so it might look a little bit dirty, but if you make a mesh, it would be more clean. But you can see all the points, and you see that you all around the cookie, we see exactly where the cookie touches the conveyor, and that is really needed to get a very well-defined XY measurement on those components. So a multi-sensor setup can sorry, I have to start again. A multi-sensor setup can overcome your occlusion issue, and even at high speed, we still can create very nice data for you for your application. Now I move over to Marion again.
Thank you. So as we just say, the Gocator has onboard tools, and for a lot of application, you can use the onboard tool of the Gocator to solve the challenge you have. And you don't need any PC. So everything is working on the Gocator, and you output directly your measurement into a PLC or a robot, for example. In the cave, you have an application where the onboard tool of the Gocator are not enough anymore. We now have the possibility to use the FactorySmart AI Solutions. So our AI system includes optimized inspection pipelines that leverage deep learning network for fast and accurate visual inspection, high-value inspection hardware for edge deployment, cloud services for dashboarding, alerting, ongoing pipeline tuning, and remote support. To illustrate what we can do with AI, I will present you some application we solve with 2D and 3D vision. The first application is the Loin sorting. So for all applications in food industry, automated inspection maximizes yields and minimizes operating expenses in meat packing factories. So for this application, our AI model was trained to classify left side or right side pork loins. Once the decision is done, it's sent directly to a PLC that switches pneumatic actuator. It doesn't matter the volume of the piece of meat or the height or the gap between two pieces of meat, because our AI model is trained to work under these conditions. So all the pieces of meat do not need to look exactly the same. The next application is the short loin portioning. So here we use a 2D camera to capture a top-down image of a sliced short loin. Our AI model is trained to find the tenderloin section. Once we identify this section, we are able to measure the height of the tenderloin, and with this height, we will be able to determine whether the meat is a porterhouse or a T-bone steak. Because the porterhouse steak is more expensive than the T-bone steak, this is important to have the classification, the right classification, because we will be able to sell the right product at the right price. The next example is the Loinpull grading. Here we also use a 2D camera, but with color, and we capture a front-facing image of the loin. With our AI model, we will recognize the fat cap and the shoulder bone. The distance between both is called the grade, and it's important to identify correctly the shoulder bone because the shape of it is used to optimize the cutting blade upstream. And if the cut is optimized, then we will have more meat and the grade will be better. And again, we will be able to have to improve the profitability because we will have more meat on our portion. The next application, rib cutting, for this one we use a Gocator and we generate a 3D point cloud. Then we convert it to a height map and we will, thanks to our AI model, recognize the backbone of the animal. This one will give you the optimized cut line to again get as much meat as possible. And once we identify this line, we send the coordinates to a PLC directly, and this PLC controls the slicing machine. As for the previous application, it's important to have the optimized cut lines so we can have more meat and again improves profitability due to higher market price. And the last application we have with AI in food industry is the sausage quality inspection. So here again, we use a 2D camera with color to take a top-down image of sausages traveling on the conveyor. With our AI model, we are able to determine if the sausages are good or if we find defects on it. And if we find defects, we will send the coordinates of the defective sausage to the PLC and trigger a mechanical system to remove this from the line and send them back for repacking. If we would have detected the defective sausage later, then we wouldn't be able anymore to repack it, and this would lead to a waste of sausage and, of course, of money.
Okay, Marion, thank you. Maybe some people question because we're saying 3D systems and now Marion is talking about 2D. That's because we have, besides conventional measurement techniques, also AI. And for AI, we don't care whether we use 2D or 3D. So we focus on the 3D images, but sometimes 2D is good enough. And this AI group is also handling 2D images if needed. I'm going to talk a little bit more about 3D smart sensors for the food industry, so about the sensors themselves. For each application, there is a sensor which suits best, fits best for that application. So within the LMI portfolio, we have a lot of line profilers, and they come with VGA resolution, so 640 points over the line width, up to 1 megapixel, 2 megapixel, and at the end, a 4 megapixel imager. Then also, if you look at the field of view for each series, can go from very small, which is 2-3 centimeters, up to 2 meters in width in one sensor. So based on the application, you have to choose the width of your field of view and the resolution, and one sensor will fit, or maybe you need to have a combination of multiple sensors. On the left bottom, we have our GoMax NX. That's as soon as we're using AI or you have a very high CPU demanding application, our Gocator will not handle all the data inside the Gocator itself. So in general, all the applications run in the Gocator itself. There's no need for any controller. But if you have really high speed, a lot of sensors and a lot of calculations, that Gocator will not handle that amount of data and processing. For that, we have in GoMax NX, which is a compact and fanless vision accelerator. You just connect it in your system. It comes up with a web interface. You just select which sensor you want to accelerate, and from there it takes over all the computing on the NX platform. If we go into the sensor series, I just said we have from VGA up to 4 megapixels. We just recently introduced our Gocator 2600 series, and that's a 3D smart sensor with 4K resolution. 4K resolution really means that you have a lot of data points on one line. Becomes very interesting if you now have a system where you have two sensors side by side, not to cover your full width of your measurement range, but because one sensor has not the resolution. So two sensors with a 1 or 2 megapixel imager can be replaced by one sensor with a 4 megapixel imager. And that makes it a little bit easier for your application. It's easier to just install one sensor compared to two sensors. On the other side, if you really have a high demanding application with high resolution, then this might be the sensor that you're looking for. So again, it's a sensor with 4,200 data points. It's high speed, high resolution for those applications where that's been required. If we go one step below the 2600 series, we have a 2400 series as Gocator. This is a 2 megapixel sensor series. And again, these we have very small field of views up to the big one, which is the Gocator 2490, that has a width of maximum 2 meters. In this application, which we show, we just go on a 1 by 1 meter, it's a 1 meter width conveyor, and we run this application at 800 hertz. Then you might question yourself, 800 hertz, is that fast enough? The sensor itself can go way, way, way much faster. The question is whether the intensity can handle that as well. So if you have very dark products, you need more light, and then sometimes your intensity might drop your sample rate. So even the sensor can be run 5 kilohertz or 10 kilohertz. If your exposure setting is 2 milliseconds, it will be only 500 hertz. In this application, we do pizza with toppings. We were set to 800 hertz, and that delivers still at a 2 meter per second movement, a 2.5 millimeter XY resolution. For this application, it was already more than what they're asking for. Gocator 2490 is, as all the other sensors, robust, has high quality data, and it is an all-in-one solution again. The pictures that Marion already showed you on this application is done by the Gocator 2300 series. This is a sensor with 1 megapixel imager, and we call it internally our workhorse. This is the sensor we sell a lot in the food industry. 1 megapixel is, and most of the times, enough for the resolution which is required for food industry. It's a simple sensor to install. It's very flexible in various designs, so you can just have one on top. You can, like you see with this application, 2 on top, slightly angled to see the sides, an additional mounted third sensor from underneath, and still combine the data. The Gocator 2300 series comes in 5 standard models, so from small to big, like also the other series. And that means you can really customize it to your application. So you take one big one for big field of view, but if you need higher resolution, you can either replace it with a sensor from the 24 or the 2600 series, or you just combine 2 sensors from this 2300 series with half the measurement range and put them side by side. For each applications, we do have a solution. And for that, I really recommend you to contact your local sales guys or the technical support from LMI, which will help you define for your application the best setup. And at the end, we just want to say the advantages of 3D smart sensors when you're going to use those. 3D smart sensors like LMI is providing those under the brand name Gocator. They do scanning, measuring, and controlling in a single device. So we do the complete scan. We add measurements to that scan, so you don't only export a 3D image, but just real measurement values. And we also control that system by using standard protocols like Profinet, Modbus, Ethernet IP, ASCII code. So everything, the only thing you need is a sensor, a cable, and you're done. And that means no external controllers are required to get a full system operational. It's a minimal hardware, and that means also lower total cost of ownership. Like I said before, the sensors are factory calibrated. You don't need any external lighting, don't need any synchronization. We've done all that for you. So you literally take it out of the box, you mount it, you connect it to your computer. You don't need software on your computer because everything is web-based, and you immediately can start configuring your sensor. Like I said, onboard measurements are there, no need for a computer. And that's the way we want to run Gocator and promote Gocator in many different applications. For food, we see even it's a very traditional market. We see a lot of new requests for many new applications. And we think we have with Gocator a very good sensor that can help you on those applications. If you are very interested in how a Gocator works, we do have a virtual sensor online. So if you go to our website, and the link is presented on this slide, you can open up the interface, and that's an offline Gocator. And we have a variety of application scenarios already uploaded for you. You can load those, and you can look at the data, and you can configure measurements and just get a feel how Gocator works for you. This also helps you when you have an installation already up and running. When I go to a customer, most of the times I bring a sensor. We just mount it on top of the conveyor. We take we collect some data, 20 seconds, 30 seconds data collection. We store that data, and afterwards in this emulator, we can open the data, we can have a look at the data, and we already can start configuring measurements. So you can do offline your complete application. When that's been running, you can download that configuration and upload it later on in a live sensor, and your application is working inline. If you still need to fine-tune, you always can record a what we call Gocator support file, upload it again in your emulator, and offline you can start doing fine-tuning. Also, if you have a problem or something's not working as expected, our technicians will, most of the cases, ask you for a Gocator support file. And that really helps them, and at the end you, for a very simple and a very adequate support handling. So please feel free to get a test on this vertical sensor, online sensor. And also we have on our YouTube channel a lot of examples for applications and explanation how Gocator works. And that being said, brings me to the end of this presentation.
Great. Thank you, Lucien. Thank you, Marion. So now it's time for questions. So if you have questions, please drop them in the chat now. Now's the time. Okay, so let me start with the first questions while we wait and some more questions pour in. So the first question I see, does LMI provide housing for the sensors?
Okay, I will take that one for me. In food, yes, people are asking for stainless steel housings and for special windows, not being glass. LMI is not providing any covers right now or special housings. The reason why is that talking to a lot of customers working in food industry, some of them require glass, other ones require plastic. So it's not a 100% non-glass requirement which we got. On the other side, it is also that a lot of our OEM customers really want to have their own look and feel if they mount the sensors. So they build their own housings that really integrate in their machine. If you're just a user for a single sensor, there are from third parties, there is a third party that provides housings which are especially made for Gocators. So that's just a off-the-shelf product which you can buy, which you can mount your Gocator in, and then you get a protective housing, which is good for food, but also for other environments. So in general, no, we are not building stainless steel housings. And yeah, we don't see the need at this moment that it's really needed.
Okay, thank you. So one question is, will the webinar be available later for those who missed it? I can take that one. Yes, you will get an email with the webinar recording. We will also upload the webinar on YouTube, so you will be able to watch this later. Another question I'm getting, how do we get the calibration jig for 6 degrees of freedom calibration?
I can answer that one. So for 6 degrees of freedom calibration, we have two possibilities. If the sensors are mounting in wide mode, so next to each other, like in the example that Lucien showed us, we will use this target with pyramids. So we have now, since the version 6.1 of the firmware, new measurement tools. The name of these tools is Surface Merge Wide. And if you use this special target calibration with pyramid, you can scan it once and it will provide you a new type of point cloud. We name it the mesh. And with this mesh, you will be able to get 365 degrees point cloud aligned with 6 degrees of freedom. This is in case the sensors are next to each other. And if the sensors are mounted in a ring, you have the second tools, and the name is Surface Align Ring. And for that, you have another target. It's a truncated double pyramid. And you need to also scan it once to get your mesh and be able to have your entire point cloud. We have on our YouTube channel another video explaining both type of alignment more in detail.
But Mario, I think the question was also, how do they get the calibration jig? If I'm correct, because we have a big variety of setups, different sensor models, we only provide the dimensions of that jig, but it's something that has to be custom made because each application requires a different dimension shape of that calibration. So LMI can assist how it should look like, but it is not an off-the-shelf product we sell. So it has to be manufactured.
Yeah, sorry, I missed this word. Yes, on our user manual, you can find some recommendations. So about the resolution you need of your target, and also how it should look like depending on the sensor type you are using. And of course, you can also always ask us and send us your drawing so we can confirm you that it will work for your setup.
Okay. Another question we got, how many sensors do you require for a cookie inspection? And are those sensors then connected to show a full inspection image?
Okay, I will take that one. The question is, what do you want to measure at cookie? So we do have cookie applications which just has one sensors over 2 meters in width. If you just want to know where the cookie is located, and if you want to do a height measurement on the cookie, then you only need one sensor. Depending on your resolution, it can be a lower or higher resolution sensor. If you really want to be occlusion free, you need multiple sensors. And then it comes down to what is the resolution you want to achieve. So for this application, which we spoke about, we go from 4, 6, 8, 12, or maybe 14 sensors, depending on the width of the conveyor. And the requirement of this application was 0.2 of a millimeter and XY. If you can live with 0.4 of a millimeter, you need less sensors or sensors with a lower resolution. So it's a really tailor-made application. And yeah, the answer is you can do it with 1 sensor, or we can use 12 sensors, depending on your requirements. So sorry, I don't really have a simple answer. Just call us and we will guide you through the specs. And together with you, we will define the best setup. And you also provide you the amount of sensors and which model you need.
Okay, great. So another question, I guess that's not so food specific, but I'm sure we can still answer it. How is your experience with transparent or reflecting objects?
I would say it's, we also won't have only one answer. It really depends on the object. So for reflecting, since we have the 2500 families, we get very good results. Also with the standard sensor, the standard profiler, because the sensitivity of the 2500 family is really good. So for reflecting objects, it gives us good result. For transparent, we have a special sensor, the 2520 and the 2522, which are developed to work on transparent surfaces and also reflective. And if it's still not enough, we have now the confocal sensor that Lucien showed us at the beginning of the presentation with confocal technologies. And this one will for sure solve your application with transparent or reflecting objects.
Great. So yeah, reach out to us if you need anything for that. The next question I also see is, are there any specific trends you see in the food industry for food applications?
Okay. That's again a very difficult question. Some of the food market is very conservative, so it takes a long time before applications are being, from the first call we get from some customers up until it's on the market, it might take 4 or 5 years. And the trends we see that there is more and more requests for 3D image in food. So where a lot of applications used to be 2D, people see the advantage of having the 3rd dimension in there. Also the ease of use, because you're walking away or going away from difficult lighting. That's one of the issues that people want to overcome, but also using the height image really helps them. It opens also new markets in food. What we see on one side is that people, where we advised first a middle resolution, 1 megapixel, that while building the sensors, we in a second, third visit, we just come to the conclusion that lower resolution will also help. So on one side, you see that people can work with low resolution, low speeds. On the other side, like the explanation, the example we showed, it's really high speed, high resolution. So it goes in 2 directions. Another one that's worth mentioning is that if you have your data, then sometimes the onboard tools will help. So we just linked with height, cracks, etc. But sometimes it's not good enough. And then AI is the new technology that really helps on very difficult and non-predictable defects or dimensions you need to measure. So LMI can provide both, and really depending on the application, it's one or the other.
Okay, great. So that's all the questions I see for now. Anybody have any more questions? Now is your last chance. I just got to give people a few more seconds, just in case. But it seems to me that may have been all, so... Oh, wait. Another question. Is there any example code showing how you do AI with the 3D data? What I can already say about that, that's, I guess, very case-by-case basis. We do have 2 webinars on our AI FactorySmart Solutions specifically. And we do look at some code there. So there is some coding involved. I'd advise you to maybe check out that webinar on YouTube. That's where you will find it. That's probably the best resource to get some more details. Anything to add, Marion, to that?
No, I think, yeah, it's the best to do.
Okay, great. So if you guys have no more questions, then thank you, Lucien. Thank you, Marion, for your time and explaining to us the details of the food industry and how LMI can help the food industry accomplish anything. Thank you so much for watching. And if you have any more questions, you can, of course, always reach us at lmi3d.com and we will get back to you. And yeah, thank you so much for spending this time with us. And we see you at the next webinar.
Thank you.